Hello guys, welcome to my YouTube channel. I hope you all are doing great. So, today is the day 14 of our Python programming course. In this course, in this part we are going to cover the exception of handling, such as exception of errors that how to actually handle the exception handling. So when running a program, unexpected error may occur due to the invalid input, missing files, or incorrect operations. These error can stop the program abruptly. Exception handling is the technique used to detect and handle such error such that the program continue and running smoothly instead of crashing. The Python provide built-in keywords like try, except, as, and finally to handle exception. So, what is exception? An exception is an error that occur during the execution of a program. When exception pro when an exception occur, such as Python stops the normal flow of program and display error message unless the exception is handled. Example, if you are going to print here 10 divided by 0, it is going to give the error as 0 division error, and it is going to crash the code. So for that, why do we actually need exception handling? Exception handling help us write programs that are safe, reliable, and user friendly. Without exception handling, the program stops immediately when an error occurs and remaining code is not executed. With exception handling, the error is handled gracefully and program continues executing, and a user-friendly error message can be displayed. So uh, this is how the exception handlings are. So let us see the syntax of try and except. So try and accept. The try block contain the code that may cause an exception. If an exception occur, the except block is except block is executed, such as you can see here. It has given try num equals to 10, and here instead of raising zero division error, what it is going to do, it is going to print this. So normally when you are not going to do that, such as here, then as you can see, it is going to give error like this here. If we are going to do that, as you can see, it is going to give the zero division error. But if we are going to write it like this here, then it is going to print whatever as you can see, except zero division error. So what it is going to, if the zero division error is going to occur, then it is going to execute this block of code. And for that, as you can see, it is a print cannot divided by 0. So this is how it is. As you can see here, the another block, as you can see, we have not um, you can see here we need to actually enter value a b c. As you can see, uh, as you can see here, when we actually going to what it is going to ask, it is going to ask please enter a number. But such as if we are not going to enter number like a b c, which a b is, which is not actually a number, so what it will going to do, it is going to raise an error, a value error. But here if we use the accept value error and write this part of code such as please enter the valid integer, then it is going to execute that. What will happen if we are going to give here value like normally such as 815, then as you can see it is going to print 15, just like this is going to work like this. So it is not going to actually crash the code. You can do as you can see if you are going to do it like this, then the code is not going to crash. It is going to be executed even either this one, or if the error occur, it is going to execute this. So the code is not going to crash. So handling multiple exception, if you want to handle the multiple exception, you can write it like this, like here, such as value error except zero division error, like this. Such as here, if I'm going to write here 0, it is going to happen, it is going to print cannot divided by 0. And if I'm going to do it like this, then a b c, then it is going to give the invalid input, since invalid input is value error. So this is how it is work. And Uh, so our next is else. So our next one is else. So what the else do? What the else is going to do if we are going to write and now going to print it like this, such as if we are going to write to, as you can see, it is going to give the try, it is going to execute try, and if the execution is has been done without any error or using exception, then this else is going to print going to execute whatever this is are, such as here the program executed successfully in else. What it will is going to happen if this is not going to do fully, such as it is going to, such as here I'm going to divide it with 0, then as you can see cannot divide it by 0, because here this code is not has not been fully executed. Then it is going to work like this. So our this is how the else is going to work. So so our next one is finally block. The finally block is always executed whether an exception occur or not. It is commonly used to release resources such as closing file or database connection. So what the finally block is always going to execute it whether it is going to raise an error or not. As you can see here, since try is 10 divided by 0, even if the zero error occurs, it is going to do that, and after that finally the program is finished, the finally has been executed. What will happen if I'm going to here, as you can see, the error is not occur, but even that even even in that case, the finally is going to execute. So here is some another example you can see. Even if there is no error, the finally is going to execute. So this is how the finally work. So let us see the complete flow of try, except, else, finally. So the complete flow of try, except, else, finally is, first we are going to write the try, after that except and else, and then finally. So this is how you always actually write it. As you can see here in this example, try num equals to number, integer number, and it will going to ask, and as you can see, if I'm going to write 0, it is going to give the zero division error, cannot divide it by 0, and it is not going to execute the else, and it is going to print the finally project finish, program finish. So even if the code is crashed, the program is going to execute. And if I'm going to write a b c here, invalid input, but the program is finished, and what will going to happen if I'm going to write here 2, then as you can see, it has printed the result is 5, and it is going to, but the finally is also printed. As you can see, the program is finished. So it is going to work like this. So catching, so our next part is catching all exception. Sometimes you may not know which exception will occur. In such cases, you can use the exception class to catch all exception. Such as here, if you are going to you do that, as you can see 0, then as you can see, it is going to print error divided by 0. It is going to, if you can use a exception class such as except exception as e, so whenever you are going to write a print error e, so whatever the error is going to occur, it is going to print that. As you can see, I have given 0, then it has printed divided by 0, error divided by 0. And if I'm going to run again and give a value error a b, then as you can see, invalid literal for integer with base 10 ab, So what will going to happen if I'm going to give here point value, since invalid literal for integer, since base 10 the 10 6.4, this is also going to give error. So what after that 4, as you can see, it has not given any error because it is an integer, so and which can be divided by 10. So this is how it is. So if you do not know which error can be occur, then you can use exception as e, like that. And so let us see commonly built-in exceptions, such as what are the Python provide many built-in exceptions to handle different type of runtime error. So let us see what are the types of error. First is zero division error, which actually occur when you are going to divide it with zero. Second is invalid error. Say value errors. It is going to raise when function receive a value of correct type but invalid value. Third is type error. It is going to raise when an operation is performed on incompatible data type. So in that case, the type error is going to raise like this. So our fourth one is name error. So name error is when an unidentified variable is used, such as here you can see I have given print age, but I have not defined where the age is. So in that case it is going to be name error. And let us go with our index error. So what the index error is going to do, it is going to print the if the index is out of range, such as here I have written list of number 10, 20, 30, but I have printed list numbers 5, because at 5 index it is nothing. Then what it is going to do, it is going to raise an index error, raised when accessing an index that does not actually exist. Our sixth one is key error, like this, such as raising here, as you can see, raising when the dictionary key is not found. Such as here the in dictionary there is student equals to name Rahul, and if you want to print age but the age is not in dictionary, then in that cases it is going to raise the key error. Say seventh one is file not found. What the file not found is going to do, if it is going to raise error like this, since if in cases like if you want to read the data but the data dot txt is not exist, then in that cases it is going to raise the error. Eighth is attribute error. So what the attribute error is, it raises when object does not have specific attribute or method, such as here is text equals to Python and I want to append 3, but in string append method there is no append method, then in that cases this is going to raise an attribute error. So it is going to work like this. So these are some errors you can try. There are some more, other errors also. You can see. So our next one is raising exception, such as what the raising exceptions are. The raising the raise uh, here. Hmm. So raising exception. So the raising exception is used to manually generate an exception. It is useful when you want to stop the program and display an error if a certain condition is met, such as raising exception is that you can create your own exception like this, and it is going to raise, as you can see it here, like this. Here, what I have here in this example, I have given age equals to -5, and if the age is less than is 0, then raise value error age cannot be negative. So whenever the age is going to be less than 5, the code is going to crash and it is going to raise an exception as value error. And as you can see, you can create your own exceptions like this, whatever the exceptions you want. Such as you want to raise your own and create your own exception, then you can create it like this. And here, uh, as you can see, password is 123, and if the length password is less than 6, then the raise the value error. Password is too short, you can raise it like this. This is not a built-in error of Python. This is something you can create like this. So our next one is custom exception, user defined exception, such as you can the Python allow you to create your own exception class by uh, inheriting from built-in expression class. Custom expression make program more meaningful and easier to understand, such as you can make a class of error exception, age error exception, and you can as pass so you can make your own exception like this, then it is going to raise the error like that. You can also make error invalid marks error using class invalid marks, exception, pass, and whenever you are going to raise the invalid mark error, it is going to raise an exception. Mark cannot exceed 100. Whenever the condition actually met, it is going to raise the error like this. So our next one is using assets asset as a statement. The asset statement is used to test whether the condition is true. If the condition is true, the program continues normally, and if the condition is false, then Python is going to raise an assertion error. Assertion error is mainly used for debugging and validating program condition. You can use it like assert condition and error message, whichever you want to type. Such as here, you have given the variable 18. Take a variable whatever you want and asset if the asset age is greater than 18, you comma you must at least you must be at least 18-year-old. And if if you are going to do it like that, then as you can see, uh, here as you can see, if here as you can see here, hmm, as you can see, whenever you are going to execute this code, it is going to run the code like access granted. And when if it is age is 17, it is going to raise an error such as you must be at least 18, like that. So it is going to raise an error like this. So you can also do it like that. So, and if your age is not, as you can see here, if your age is not under 18, it is going to give an error like this. So This is how you can actually do it. So these are some example such as balance equals to 500 if assessed balance is greater than equals to 0, balance cannot be negative, and transaction print transaction complete since balance is more than 0 is its transaction complete. And if I'm going to here minus add minus, then it is going to raise an error as it cannot be negative, balance cannot be negative. So it is going to do it like this. So these are some as condition. If the condition is if the condition is true, it is not going to do anything. If the condition is false, it is not going to do anything. If the condition is true, then it is going to raise the error. Second, exception handling with file object, such as here in many cases, like if exception actually happened in while in file handling, such as file not found, so you can actually print it like this. You can take the try with open like this, and in accept file not found, print file not found like that. So if you are going to run it, even if the file is not found, it is not going to raise an exception, raise an error. It is going to print file not found. And here is the another example. Since if you don't know, do not know the error, such as that you can also write it like except exception as e, print error e. So it is going to print the error which is happen. As you can see here, it is printed no such file on directory student.txt. So this file is not actually present in it. It is going to print like that. So our next one is nested try except. So a nested try except means one try except block inside another try or except block. It is useful when different part of program requires exception separate exception handling, such as in this example you can see here it is an input number, and if the if so if the value error actually in here, if the value error actually happened, then it is going to go that directly to the value error and print it. So this block of code, it is going to skip it. But if you are not going to do the next step, then it is also going to check this one, and this one, all of this. So this might actually give problem, even if the error does occur, because so it might actually going to check whether the exception, like this exception, it is also going to check whether this is the exception, this is the exception. So it is going to do it like this. So this is how it is going to do. When out try except handle, it is going to handle this. So these are how the try and except are being used. You can use it in this such as mobile application, data validation application. There are many uses of it, as you can see. So let us do some coding question, such as write a program to handle a zero use. Hmm. Yeah, so let us go with our first question. Write a program to handle error, zero division error using try except question 1.py. So first what we are going to take, we are going to take two inputs, such as first input is a equals to and input enter number. Here first second a b, after that try parent a a divided by b except zero division error, print cannot be second second number cannot be zero. So when you are going to run this code, even such as for first number I am going to take 3, and for second number I am going to take 0. As you can see, it has printed second number cannot be 0. So it is going to print like this. So our second one is, let us go with our second question. Question 2.py. So our second question is write a program to handle invalid user input using value error. So you can do that, try. We are going to here copy this. Here I'm only going to write a simple code as print n except value error, print invalid input. If, as you can see, if you are going to run this code, if you are going to write here 3, it is going to print 3, but if you are going to write here a, it is going to print invalid error. And as you can see, as for at the rate, it is still going to print invalid error, or any another character such as 2.3, it is going to print 3.4, then it is going to print invalid error. Since it is not an integer, it is a float value, so it is going to print an invalid error like this. So our third one is question 3.py. Write a program to use try except to divide to number, try except else. So we are going to use this one like here, try after that else. For that we are going to result result equals to a divided by b. After that print result, so it is going to print like this. uh, you also need to remember here. Yeah. So for first number 3 and for second number 4, as you can see, it has printed successfully. And if I'm going to do that, the first number 53, second number 0, then it is second number cannot be 0. And if I'm going to write 0 for 4, then it it should be 0. So it is going to print like this, as you can see. So let us go with our fourth question. Question 4.py. Write a program that demonstrate the use of the finally block. So we are going to do that. We are going to take this example and accept we will going to copy this and print it here, and except for this we are going to do finally print program ended. Program ended. Then if you are going to write 4 and 3 4, it is going to be, as you can see, it has printed program error ended and the result. And if you are going to 3 divided by 0, then second number cannot be 0, and after that it has program ended. So it is going to work like this. So let us go with our second question. Write a program to handle both zero and value error. Question 5.py. We are going Control C, Control V, and as for the except value error, print invalid input. So if we are going to write here A, as you can see, it is going to print invalid input, since if the error is going to be value error, it is going to print it like this. And if it is 3 0, as you can see, the second number cannot be 0, so it is also going to do that for zero division error. So you can do it for both like this, using to accept. So our sixth question is write a program to catch all exceptions using exception, such as question 6.py. We are going to take this one. After that, here, after accept exception as E, after that print error, comma E. So as you can see, whenever you are going to be such as A, as you can see, invalid literal for integer with base 10. So it is, as you can see, it is going to raise an error like this using exception. using exception class exception function. So let us go with our next question. So for our next question, write a program to raise value error if the entered age is negative. So let us question 7.py. Uh, so what are we going to do? We are going to a equals to age equals to int input enter age. If age is less than 0, then raise value error age cannot be negative. Negative. Otherwise, print and here print age comma age. So if age is 43, it is going to be print the age, and what will happen if it is 13, and as you can see it is also going to print 13, and what is going to happen if it is less than 0 such as -1. So as you can see it is going to raise an value error like this. So this is how you can do it. So our eighth question is create a custom expression exception name invalid age error using it in a program. Question 8.py. So for age 1 we will go what we are going to do. First we are going to create a class invalid age error exception pass age equals int input enter age. After that try if age is less than 18, raise invalid age error, age must be 18 or above. Print eligible, otherwise except invalid invalid age error as e print e. So this is how you can do it. So if I'm going to write here age 18, as you can see, it is going to print eligible. And if I'm going to write 813, it is age must be above, age must be 18 or above. It is going to raise an a this error and it is going to print that. So let us go with our ninth question. Write a program using a asset statement to check that the number is positive. So question 9.py n equals to n equals to int input enter a number. Assert, assert, assert and less than 0, comma, number must be positive. Print valid number. So if the number is going to be positive, then it is going to, such as here, if it is 12, it is going to print the valid number, and if it is minus 34, it is printed assertion error. number must be positive. So it is going to raise an error like this. It's going to raise an assertion error. So for our 10th question, it is write a program to safely open and read a file using uh, exception handling. So mm, question 10.py. First is try with open message dot txt as read as f print f dot read. Except file not found error print file not found. So this is how you can print it. As you can see here, since I do not have a file name message.txt, so it is going to print the file not found. Since I do not have message.txt in my directory, in this directory it is going to print file not found, and if I have, then it is going to read its content. So with that, we have finished our some coding practice. So these are some our coding questions. I hope you all are going to try it. I have written here some questions. Hmm. With that, we have finished our file error exception handling of Python. I hope you have liked this video. So please like the video and subscribe to my channel if you are first one. So see you in so thank you.